Hello everyone! In this video of the Bicycle LCA series, we will start LCA with modeling of aluminium frame and then interpret the results of LCA. To give you an overview of the network diagram, we will start by adding raw aluminium and use electricity to produce 1.5 kilograms of aluminium needed for frame manufacturing. Let's open SimaPro. Start a new project. Select the libraries. We are using System Library because calculations are faster in it. We also need to select methods. Let's add goal and scope of the project. The goal is to compare the environmental impacts of bicycle using different frames over its entire lifetime. The functional unit in this case is cycling 100,000 kilometers over a lifetime of 15 years. In accordance to the functional unit of a bike, the appropriate reference flows would be the amount of products needed to fulfill the functional unit. These are one frame, 2 wheels, 1 handlebar, 1 group set, a set of brakes, 1 saddle, and 1 cardboard packaging. The alternative scenarios could be variable weights of bike, variable types of materials, and variable transportation distances. Don't forget to save the project. Now we are going to model the production stage impacts of the different bike frames. We will create a new category in the processes under Material. Right-click on Material and select New Category. By starting the name of new category with an underscore, it will appear on top of the list under Material. Click New on the right and name it Aluminium Frame in Outputs to Technosphere, Products and Co-Products field. Enter its amount as 1.5 kilograms. Allocation will be the default 100%. Under the Waste Type field, choose Aluminium, since we are modeling an aluminium frame. The aluminium frame is constructed using the materials and processes shown in the table. Under Inputs from Technosphere, Materials/Fuels field, enter the materials and processes involved to produce the aluminium frame. Select aluminium primary ingot for EU27 and EFTA. Enter 1.579 as the amount. Here we consider 5% as production loss. Now add powder coat aluminium sheet. Enter the amount as 0.375 square meters. Add impact extrusion of aluminium. If you are not sure where to find a process or material, click on Show in List, and it will show you all the materials and processes in the selected database. Enter 1.51 kilograms as its amount. Add welding arc aluminium. Enter 0.75 meters as its amount. Click on the field of inputs from Technosphere, electricity/heat. Now add electricity medium voltage, aluminium industry for EU27 and EFTA. Enter the amount as 31.5 kilowatt hours. This electricity is used for bending, hydroforming, furnace, quench tank, and screwing processes during the frame production. In the outputs to Technosphere, waste treatment field, add aluminium waste treatment and enter its amount 0.079 kilograms to get the mass balanced. Save the project, click on Aluminium Frame, and then click on the Network button. In the name field, enter Network Diagram of Aluminium Frame. Leave the comment field empty. Double-click the line under the Method field, choose Global on the left side, and then select Recipe 2016 Endpoint, H Method. Choose World 2010, H/A below under the Normalization/Weighting set. This method was chosen for this tutorial since it covers a wide range of impact categories and includes weighting to calculate single score results. Enter 1.5 kilograms under the amount field for the aluminium frame, since we have to model the impacts for assembly of 1.5 kilograms of aluminium frame. Long-term emissions are emissions that occur after more than 100 years. When they are assigned to specific subcategories, labeled long-term, it's possible to distinguish them from emissions occurring within the first 100 years. Click on Calculate button at the bottom. The network diagram of aluminium frame appears. With Navigator, you can adjust the size of diagram. In the current view, impacts are shown in percentages. If you turn it off, impacts will be shown in terms of points. If you take a look at the thermometers and indicator values, you can see how many points each material or process contributes to the aluminium frame production impact. Currently, the single score type is selected, which gives the single score environmental impact of the aluminium frame. You can also explore other options like inventory, characterization, damage assessment, normalization, weighting, and single product flow from the drop-down box. The button Show Cumulated Indicators allows you to see the flow indicator as an aggregated result. Having this option selected, you can see the contributions of the different materials and processes to the aluminium frame production impact. The button Show Flow Indicator in line width allows you to create a Sankey diagram. This means that the thickness of the flow line depends on their environmental impact. Navigator feature is used to navigate through the nodes in network. You can zoom in or out and drag the blue box to determine what you want to see in your screen. Use the Fit to Page button to reset the setting and show the full network again in your screen. When you click on the Impact Assessment tab, you'll see the characterization result of the production of 1.5 kilograms of the aluminium frame. When you click on the Show Table icon at the top, you can see the normalized score of the materials and processes involved in the production of the aluminium frame for the various damage categories. The Chart Settings icon allows you to change the colors of the graph bars, series, and background, and it allows you to edit the legends and axes of the graph. If you are unable to see all the text and legends, then font size can also be changed from Tools. The chart settings can also be changed by right-clicking on the empty space in the chart. If you click on the bar chart columns, the exact percentage contribution of the different materials and processes to the corresponding impact category can be seen. When you click on the Damage Assessment tab, you will see the damage assessment results. They are similar to the characterization results, but now the endpoint indicators, damage to human health, ecosystems, and resources, of the recipe impact assessment method are calculated. The difference lies in the fact that in the damage assessment, results are presented in a more aggregated manner. The aluminium primary ingot has the largest contribution to human health, which is 61.1%. The damage to ecosystems by aluminium primary ingot is 53.8% and 66.8% to resources. When you select the Per Impact category box, you will again see the characterization results of the aluminium frame. When you click on the Normalization tab, you will see the normalized contribution of the different materials and processes to the impacts of the aluminium frame production. These results express the relative contribution of the different materials and processes used for the aluminium frame to the average environmental impact of one person in the world per year, since you chose World 2010, H/a normalization/weighting set, while selecting the impact assessment method. When you click on the Show Table icon at the top, you can see the normalized score of the materials and processes involved in the production of the aluminium frame for the various damage categories. For instance, in this case, you can see that the production of the aluminium frame has an overall normalized score of 0.0026 for the human health damage category, which implies that the environmental impact for production of 1.5 kilograms of the aluminium frame is equivalent to the human health damage impact caused by 0.0026 person per year, or 0.26% of human health damage caused by an average person in a year on a world level. Similarly, You can interpret the results for the remaining damage categories or according to the specific materials or processes. Select the Per Impact category box to see normalized scores according to the different midpoint impact categories. When you click on the Weighting tab and then click on Show Chart, you will see the weighted results for the production of the aluminium frame. Weighting multiplies the normalized results of the different midpoint impact or damage categories with a weighting factor that shows the relative importance of the impact or damage category. Click on Show Table. The production of 1.5 kilograms of the aluminium frame has an overall weighted score of 1.09 points, which means that the production impact of 1.5 kilograms of the aluminium frame is equivalent to that of the impact caused by an average of 1.09 persons in the world per year. The unit used for expressing the environmental impact is points. When you click on the Single Score tab, you will see the single score results for the production of the aluminium frame. This method gives the environmental impacts of the different materials and processes used for the aluminium frame production in a single score. In this case, the single score results are expressed in millipoints, which is equivalent to 1/1000th of a point. Click on Inventory tab to see the environmental impacts caused by the different inventory substances for the different materials and processes involved in the production of the aluminium frame. The inventory window has many different features. You can sort the order of the substances with a click on the substance heading. You can select the drop-down box of compartment option to view the environmental impacts of different inventory substances according to their compartments. For example, raw material, airborne emission, waterborne emission, etc. Select the indicator drop-down box to view the characterized results, the damage assessment, the normalized results, the weighted results, or the single score. Select Single Score to use the cutoff feature. If the cutoff is adjusted to 1.6%, this analysis will show all the inventory substances in the network that contribute more than 1.6% of the total environmental impact. Click on Process Contribution. Here you will see the environmental impact contribution of each material or process to the production of the aluminium frame. Click on the Show Chart icon to view these results in the form of a graph. Here you can see that use of the aluminium primary ingot material is the main contributor to the environmental impact of the aluminium frame production. When you click on the Setup tab, on the General tab, you can view the impact assessment method and model details you entered for determining the impacts. The Checks tab allows you to check which and how many substances in your model do not have a characterization factor in the use method. In this case, 536 substances are not defined. When there is no characterization factor available in a method, this can mean two things. There is no environmental impact of a certain substance according to that method, or there is simply no characterization factor determined within this method. The Product Overview tab gives you an overview of the library you have chosen, the project you are working on, and the materials and processes used in your model. In the next video tutorial, we are going to add frames made of titanium, carbon fiber, and steel, and then compare the environmental impacts of the 4 frames. Subscribe for more videos.